Another classification algorithm or classifier is called the Naive Bayes. Now, Naive Bayes is a probabilistic algorithm that's based on the Bayes theorem. The Bayes theorem or the Naive Bayes makes some key assumption that each feature makes an independent and equal contribution to the outcome. So, for example, we have a data set here that has the following features: outlook, temperature, humidity, and wind, for example. Each of these have their different values, right? And the decision here, the outcome here, is to determine whether to play golf, which is yes or no. So independent here, or we just mean that, so rain here, or maybe the temperature being hot here has nothing to do with humidity being high, right? They're actually independent of each other, right? Secondly, here, each of these have equal importance. So just knowing temperature and humidity, right, you can accurately, determine the outcome. So we need to look at all this as a whole. Now, Naive Bayes is given by this equation, right? So the probability of A being true, given that B is true, is given by probability of B being true, given that A is true, that or product of that with or multiplied by the probability of being true. So given this evidence, right, divided by given the evidence of B, right? So if we were to create a feature vector out of this, so A here will be our X and B will be our Y, right? So so for every X here, so in our case here, X will just be outlook, for example, the values rainy, hot, high, false. And then the value for our Y, B here, will be probably no. So that will just be one feature vector, all right? So Naive Bayes will have to, so you will generate a table, right, with the probabilities for each of these Xi in X, right? And every possible outcome for Yi in Y. Okay. Anyway, so there's a mathematical equation going on there. So I wouldn't get into much detail, but that's the key idea here. So again, here, if you go to the API reference for scikit-learn, you can see we have Naive Bayes here. So you click on that. In our case here, we're going to be using the Gaussian Naive Bayes, all right? So the assumption here using the Gaussian Naive Bayes is that we, the feature, so the features are assumed to be normal, rather they assume to follow a bell-shaped curve, right? So that's the assumption with Gaussian. Gaussian just means, a normal distribution. Okay, so with that, then we just import the libraries. The only difference here now is that we're importing this algorithm, Gaussian Naive Bayes, right, from this Naive Bayes module. All right, so we import the data set here. We call it df. We divide the data into X and Y, and the test size here will be 80% training and 20% test, and then we apportion and to Y test, Y train, X test, and X train. We instantiate our new classifier and we call it NB_CLF so that we can now use it to fit into our model. So this is where we train our training data set that has both the features and the outcome, right? So we train this and then we use our model, the results from our model, to predict on our test data. Remember the test data here, the 20% here that we created. Okay, now we store that into an object called ypred. Okay, now we use this accuracy score, precision score, recall score, F1 score from the metrics, right, to evaluate and measure, or rather to assess the performance of our model using the accuracy, precision, recall, and F1 score. So again, we print it out. So we run this, and we can see here our accuracy is 76%, precision 76, recall, the one that we want to pay attention to, is 58. F1 score is 66%. So we can generate a confusion matrix here. Now, compared to our last algorithm, so if I just move back here, last algorithm, you can see recall was 61%. So clearly here, seems that a decision tree is doing much better than Naive Bayes, right? So next, we're going to look at support vector machine and see how that performs as well.